The half-life of a radioactive isotope X is 20 years. It decays to another element Y which is stable. The two elements X and Y we found to be in the ratio of 1:2 in sample of a given rock. What is the estimated age of the rock? This question involves the concept of radioactive decay and the relationship between the parent and the daughter isotopes. The ratio of radioactive isotope X to its stable product Y is given as 1:7. This implies that out of every 8 atoms, 1 atom of X remains and 7 atoms have decayed into Y. The number of atoms remaining after a time t is given by n is equal to n naught into 1 by 2 to the power t by t, where n naught is initial number of atoms of X, n is the number of atoms of X remaining after time small t, and capital T is half-life of X and small t is age of the sample. From the given ratio X is to Y is equal to 1:7, we get n is equal to n naught by 8. Substituting n into the decay formula, we get n naught by 8 is equal to n naught into 1 by 2 to the power t by 20. And dividing through by n naught, we get 1 by 8 is equal to 1 by 2 to the power t by 20. And solving for t, we get 1 by 8 is equal to 1 by 2 to the power 3, which means t by 20 is nothing but 3. Therefore, t is equal to 20 into 3, which means 60. Therefore, the age of the rock is 60 years and the correct option is A.